Hi. First of all, I would like to encourage you all that you do ask questions and interrupt me if you have anything you want to comment on. One of the purposes of giving this presentation is that... Sorry. Okay, I'll start over again. What I was trying to say is that you please interrupt or comment or afterwards on the presentation, as my main reason for giving the presentation is that I need feedback and I would really love to hear what other people have experienced regarding integrating networks. So, yeah. The background for this is that in 2004, our company TDC, that some of you might know as Tele Denmark, acquired Song Networks, a Scandinavian network, which was AS3246. And we decided relatively fast that the two networks were supposed to be merged into one network in order to provide support for products all over the area. And the main product that we wanted to support was Layer 3 MPLS VPNs, which were the main reason for acquiring the network in the first place. So how do you do that? We had two networks. They were both running ISIS as IGP. They were using BGP for VPN and internet routes. So it seems like a pretty straightforward thing to do. Just merge the ISIS domains, change the AS numbers on the PEs and the Ps and the line configuration, and we're all done. Should be done in a couple of months, and we'll all be very happy. This was back in 2004, please. So the world does not look like that when you're out in the real life. The acquired network consisted of 4 areas, which was basically spread out on 4 Scandinavian countries, each operated and designed by a local group of engineers. And the fact that we acquired that network did not change the fact about who were engineering and running the networks, at least not in the beginning. So for each of these 4 areas, we had a different set of issues that we had to take care of in order to integrate the networks. And a couple of examples is that in one area we had basically 2 parallel networks that was spanning the same area, running each a different AS and different customer configurations and all that kind of thing. Other areas consisted of all types of equipment that would not support our security requirements and so on and so forth. So that meant that each area had their own specific issues to take care of, so we could not do like a big bang integration in one step. So we came up with a plan that find some way to split part of the network, of the acquired network, from the rest of it, and then do an integration of that part that was split out. And when that was done and over, we could start on working on the next one. So that was what we were trying to do. Okay. So, but in order to get started on this one, we needed to get the MPLS Layer 3 product, Layer 3 VPNs, working, spanning the 2 different ASs and the 2 different networks before we could sort of get starting on working on the integration. So that's what we call the RFC 4364 Jumpstart. So that was how do we make the customers' VPNs in the 2 networks talk to each other. So we could use the option A option, which is to connect the VRFs in the 2 different networks by setting up a back-to-back connection. So we started out doing that, but if you guys should start out and try and learn from what we did, don't do this. It seems like easy and simple, but when you're going to merge into when you're going to change the configurations back because you have integrated your IGP or you want to do the option C thing that we're going to talk about, you have a hell of a lot of pain by migrating the customers, believe me. Instead, we would recommend that you use the option C option to connect MPLS networks. And in short, that consists of you have eGPP sessions where you send a label on border routers between the two networks. So that will give you MPLS label switch path from end to end, from one PE in one network to the PEs in the other networks. And then you have eBGP sessions between your VPN route reflectors in order to exchange the customer's routes. So next, we will try to go through on how can you do that. And here's a little drawing of the two different options. So on top, we have the option A connection, where each VRF that you want to connect, or each two VRFs you want to connect, one in the 3246 AS and one in the 324092 AS, you need to configure the customer on the link between the two networks. In the option C case, you just need to have the option C connection established, and then you could get things done automatically. Okay. Yeah. So I'm going to go into the details about how you make an option C connection. What it consists of is that you use eBGP to signal the loopback addresses and the labels for the loopback addresses between the two ASs. And then when you receive the loopbacks, you redistribute them from BGP into your ISIS or whatever IDP you're using. You need to enable MPLS forwarding on the links between the two networks, and then you have created a possibility to have the label switch path from one PE to another PE in the two networks. And you will be able to switch traffic on the link as well, which is a minor detail, yet you want to make sure. Yeah, so we're going through the actual configurations of this. And please interrupt or comment if you have any of those things. Yeah. First, for your... Yeah. This is how do you get your loopback addresses into the BGP so you can actually send them to the other network. I'm sorry about the dots in the, they were supposed to be removed on the slide. So you have your router BGP configuration, and we have the statement, the redistribute ISIS level 2 route map into BGP. The route map is on the next slide, and then you have the neighbor where you announce your BGP, and then you accept something from your peer, and then don't forget the send label statement, which is the one that will make sure that you actually send the labels to the other network. Yeah, and also when you're doing this, you have to be very careful about doing the right route maps and prefix lists. So be careful that you do not redistribute your own ISIS loopbacks into your iBGP, because then you get a lot of routing mess and loops going on. So here are the route maps, which basically just is a prefix list of your loopback addresses. And the inbound route map is where you would accept all your loopback addresses from your peer, and you will also accept the labels from the peer. And the outbound route map is that you send your loopback addresses and that you set the labels and send the labels as well over the BGP session. And then below, is it possible to see the last lines? I hope so. The last lines on the slides are just the loopback prefix lists. So, okay, so now we have sent the loopback addresses to the other network, and now we need to receive loopback addresses over the BGP session, and how do we redistribute it into ISIS. You do that under your ISIS statement, and then you, yes, redistribute the route map. Again, you have to be completely sure about which addresses do you want to redistribute and which addresses do you not want to do that. So that's why we have all the prefix list stuff going on. And also, just to be safe, we have a small precaution that we do not redistribute more than 1,000 prefixes. So in case of an error, we do not take the whole BGP table and redistribute into our ISIs. Strongly advise not to do that. Yeah. So here is an output of the routing table, trying to show an IBGP on an loopback address from our peering network. And we see that we are getting the address from the option C connections, and we have the next hop is the link address, and then most importantly, we see that we have labels on that route over the external link. And here is the same, you just show IPsef. And the main point of this slide is to see that we have labels on the route. So it is label switched over the interface. Okay, so that was the configuration. So how do we actually do the whole process of splitting up the acquired network? So we're going to try and illustrate this. If you have a look at the drawing, we have the white routers, that is the 3292 routers, and the colored routers are 3246 routers, and the goal is to split the yellow routers out and integrate, in order to be able to integrate them ISIS and BGP-wise. So we call the yellow for area 2, and the blue routers are area 1, and those are the part of the remaining network. So in the beginning of the operation, we have a connection. We already have an option C connection between the white network and the blue, and the two areas are still connected with ISIS links. And we have a transit connection from the peer router to the blue network. And why do we want to do this? So the purpose of it is to split it into two ISIS domains, so we could be able to flush so we are able to flush the ISIS LSPs that we do not need in that area that needs to be integrated. And another reason for doing this was that we also had authentication issues in parts of the network that needs to be fixed. So this part that we want to split out to integrate in the first operation does not have those issues. And then good advice, if you want to do this, is to lower your LSP lifetime. Otherwise, you can wait quite a long time to have the whole table flushed. Okay, so this is the next step in the operation. Now what we do is that we established a link from the 3292 routers into the yellow area, and on that one we configured two VLANs because it was an Ethernet link. On one VLAN we made a pure IP transit connection, and on the other one we configured an option C connection. And on this option C, in the direction from the yellow to the white, they signaled all the loopbacks just from the yellow area and the labels with them. And in the direction from the white network to the yellow network, we would also signal not only the loopback addresses from the 3292, but also the loopback addresses from the area 1, that is the blue area. Similarly, we would change the configuration on the existing option C between the white part of the network and the blue, so that on top of the white loopbacks, we would also signal loopbacks from the area 2, that is the yellow part of the network. And from the blue part of the network, we would only signal the loopback addresses from that particular part of the 3246 network. So, yeah, that was what I did. So now we have the situation that we have split out the signaling so that on the top link we had only the loopback addresses from the yellow part were exchanged on that connection, and only the loopback addresses from the blue part of the network was exchanged on the link between the white and the blue routers. So in this situation, raising the metric on the link between yellow and blue, on the direct link between the yellow and the blue part of the network, would then cause the traffic to, the MPLS switch traffic to move to the links and go over the 3292 part of the network, which is following the green route on the drawing. So that made quite a smooth transition of the traffic between the two parts of the network, so we could now shut down the ISIS link without causing any packet loss or anything for the customers. Okay. Yeah. So after shutting down the link between the two parts, what we needed to do then was just to wait for the lifetime of the LSPs to time out. So we were sure that we only had the LSPs that we wanted to have in the network before we could shut down the option C and configure ISIS on the link. And then we were done. Okay. Oh yes, just to make sure, we kept the transit connection between yellow and white in order to keep the traffic there. So how does traffic run now? We have only talked about the MPLS traffic so far, but how does internet traffic run in this situation between the two ASs and between customers in the two ASs and between customers in 3246? So internet traffic between 3246 customers in area 1 and in area 2, and between customers in one of the area and an IX in one of the two areas, would all go over the LSPs, and that is over the new ISIS link and over the old option C connection. Internet traffic to customers in yellow area would go via the transit connection that was on the new ISIS link, and in blue area there would be no change. The internet traffic would go the way it always had gone over the transit connection. So the interesting part could be internet, what happens when you start actually converting PE routers in the yellow areas to the new AS 3292. So we now have a gray router up in the corner in the yellow network, and it is now converted to 3292. How does traffic flow then? Well, ordinary internet traffic and traffic between customers in the rest of 3292 just flows over the ISIS. There's no problem and no change in that. Also, traffic to customers in the blue area would just flow over the transit connection, because that was just a different AS now. But traffic between an internet customer on the converted router and an internet customer on a PE router in the yellow network, we have to be careful what we do here. In this case, we have to leak more specific 3246 routes to the converted router. Otherwise, we would have the traffic follow the red path, which is red because we don't want that. Because in the case we did not leak the more specific, we would go and send the traffic to the aggregates that is announced on the transit connection to the blue network. And then the traffic would move into the blue network and use the option C and the ISIS link to go back to the customer in the yellow network. That is not a desired situation. But it was easily fixed by leaking the more specific internet routes. Yeah. So a little checklist about what you need to have in place if you try to do this is have a low LSP lifetime in the domain you want to integrate. Otherwise, you have to wait for a really long time for the database to purge. And also, you need to be in total control if you want to do authentication, or if you don't want to do authentication. You cannot have some parts doing it and some parts not doing it. And that is almost about it, except that you also have to have total control of which loopback addresses are used in which areas of the network. Yeah. So a little bit about the actual networks that we did this in. 3292 is a flat layer 2 domain. And before we started integrating, we had about 1,300 LSPs. That includes the pseudonodes. And 3246 was also a flat layer 2 network with about 600 LSPs. And now we are about 2/3 of the 3246 have been integrated now, and we have around 1,600 LSPs now. The two numbers does not add up. That's because we have been taking down a lot of routers in the process as well. Currently, we don't see any need to split the whole network into layer 1 or layer 2 domains. And we haven't had any issues after we have done integration. It's been all very smoothly. So what type of gear have we been working on, and where do we know what to do with ISIS? We've been working on 7200, 7300, 7600 GSRs and CRS1s. And we were running iOS 12.3, 12.2 SB, 12.2 SRI, and so on and so forth. And we also had some Junipers in the network, MTIs, M160s, and M320s. Yeah, for the configuration examples I had, we also had option C connections done on Junipers, so that in case anybody want to know how to do it on Junipers, just send us an email and we can tell you. So now I want to talk a little bit more about why do we like the option C connection option better than the option A. So option A is very easy to interconnect two VPNs into different ASs, but you do need configuration for each customers on the link that are interconnecting the two networks. If you want to add some more capacity, you have to move the customer's configurations to either more circuits or to a new circuit with more capacity on. QoS mapping is not really that easy. And also you need to be sure that the routers that you do the interconnect on is scalability, because you need to carry all the routes for every VRF that you're going to interconnect. If you use your option C, which is more a connection between the two networks, more considered as a backbone connection between two parts of a network, you do not need any customer configurations on that one. You just make it as you would make any other backbone connection. Sorry. The VRFs are configured on the PEs, but not, again, only on the PEs in both networks. You can make QoS work end-to-end, and you would have services as Ethernet over MPLS, via PLS, and all that kind of stuff would work over that connection as well. And, well, for where I work, adding capacity to the link would also be quite an easy task compared to the other one. So we try to make a drawing on how do we set up the customers and how do we make sure that the customers' VRFs are connected and that they work. So we have the two networks, 3292 is the blue one and 3246 is the green. And we have an upstream connections between two AS border routers. And then we have an eBGP session between the VPN route reflectors. So we have customer who is, this is a new customer, so we're setting him up from scratch so that he will work in both networks right away. So we just make sure that we have the same RT-RD configuration in the two networks, and then when the routes are exchanged on the BGP session, then they are imported into the VRF right away, so it's simple and works. On the next slide, we have a situation where we have a VRF in one network with one RT-RD, and we have an existing VRF in the green network. So how do we connect those two using the option C connections? What we do is that we pick one network, and in that one configuration, we just add a route target that matches the route target in the 3292 network. Now we have the right route target, and we make sure that the routes are imported into the VRF on the 3292 PE. So, yep. So where are we now? We have split out two domains of 3246 and integrated those, and that went very smoothly, and we had no major issues. And the last part of the network is supposed to be integrated within the next couple of weeks, according to the plan. So we have people quite busy right now doing the preparations for that. And questions and comments? If you have anybody later, please feel free to email us, but also please come and ask now.
Hi, Nina. Guy from Limelight. I was just wondering if you could go over some of the ISIS authentication issues you mentioned, because I don't really understand where that would come into play, really.
Okay. Michael.
Actually, what we had some network gear in the network we tried to, or we were integrating that didn't support authentication. And actually, you need all LSPs to be authenticated. So either you disable authentication or you authenticate all of your LSPs, because elsewhere, when you exchange them between routers, they would not get acknowledged, and you would simply just have the traffic being on the link, so to speak, all of the time. So what we've done for the authentication is to configure authentication in the integrated, or the network we're trying to integrate. But you can configure sender only on Cisco and the equivalent on Juniper. So the LSPs are authenticated, but the authentication in the network being integrated isn't used, so to speak. So when the LSPs are being flooded into the 3292 network, authentication is there. Another possibility, of course, is to get rid of the hardware that cannot do authentication for ISIS, and or not to run ISIS on those boxes, and that has also been done. So take care of the ISIS things, and also be very, very sure about which loopbacks are being redistributed between the networks, so you aren't creating any loops. Things can go horribly wrong if you aren't absolutely sure about what you're doing. But if you are that, and as Nina has mentioned here, actually it's quite easy, somewhat to do, and MPLS gives you a lot of tools to route traffic the way you want, so to speak.